Example 24, page 414. Verify that the function y is equal to c1 e raised to x cos bx plus c2 e raised to x sin bx, where c1 and c2 are arbitrary constant, is a solution of differential equation this. Okay, as you know, here is given two arbitrary constants c1 and c2. So we have to differentiate this function two times to getting the solution of this. Or in short, in other words, we have to solve a question of derivative that y is given, then prove that this, right? Because this is a solution of this differential equation. So this is a new type of way to ask the question in exam, right? So this is one of the question of derivative जो हमने solve किया था वही है और कुछ है नहीं ज़्यादा. So this is given, we have to differentiate two times and we are following all the procedure as we did in differentiation, right? So here y is equal to given c1 into e raised to ax cos bx, right? Cos bx plus this is c2 e raised to ax, c2 e raised to ax into sin bx. Sin bx. This is equation number 1, right? As we did. जिसका डिफरेंशिएशन करे इसको नंबर देना है, सिंप्लीफाई करना है, राइट? आगे का इक्वेशन यूज करना है. यदि नहीं होता है तो इसका अगेन डिफरेंशिएशन करना है, आगे का इक्वेशन यूज करना है, तो आपका आंसर आ ही जाएगा. वही करना है हमें, राइट? तो डिफरेंशिएटिंग विद रिस्पेक्ट टू x वी गेट y1 is equal to. Now I'm taking, but before that, I want to take this e raised to x common for our simplicity, right? So I'm taking e raised to ax first common. Okay, so e raised to ax is common. So remaining will be c1 cos bx plus c2 sin bx, right? So if we take this common, then we get the answer early and easily, right? Say result number 1. Now differentiating with respect to x, we get y1 is equal to, this is u into e, so I am keeping e raised to x as it is and differentiating this function. C1 is constant, derivative cos is minus sin bx, but bx, so multiply by coefficient of x, right? In integration you have to divide, but in differentiation, remember this thing, you have to multiply, so answer will be minus b c1 sin bx, right? Plus sin bx, derivative cos bx into b, so this is b c2 into cos bx plus, now this is as it is, so keeping this as it is, so c1 cos bx, I'm writing here, right, plus c1, that is best thing for you, cos bx, and derivative of cos bx is b, right? No, we have to take this, keep this as it is. So c1 cos bx plus c2 sin bx, and derivative of this is e raised to x into a, so a into e raised to ax, and this term we doesn't require, otherwise it makes a problem, so I have to remove this. Okay, this is not required term. Got it? Now taking b common from here, what we get? y1 is equal to, right? Differentiating again, right? Before that, we have to simplify this. So taking b common, okay? So I'm taking b common. Remaining term will be, I'm writing positive term first. So c2 cos bx minus c1 sin bx, and as you know, this is c. In C equation number 1, e raised to ax is this, right? c1 cos bx plus c2 sin bx. So this thing is, this and this is your y. So this is plus a and y from 1. So this is a small equation now. Again differentiating this equation, right? So y2 is equal to b e raised to ax as it is, and derivative of this is, derivative of cos is minus sin, so we get minus b c2 sine bx minus derivative sign is cos, so we get b c1 cos bx, right? Plus keep this as it is, so plus we get c2 cos bx, c2 cos bx minus c1 sin bx as it is, and derivative of this b is constant, so as it is, so b as it is, and derivative of e raised to x is a e raised to x, that you know, so a e raised to ax, this is known, and plus I'm writing here, okay, a is constant and derivative of y is y1, right? Now we have to simplify, so we have to first go for equation number 2, so this is equation number 2. Now in equation number 2 there is a term b e raised to ax, so this is b e raised to ax, right? Then c2 cos bx minus c1, so this is your term, this, so this will be y1 minus a y1 from 2, this is y1 minus a y1 from 2. So substituting that thing, taking b common from here, minus b in fact, so if we take minus b common, then what we get, c2 sin bx plus c1 cos bx, so c1 cos bx, right, c1 cos bx plus c2 sin bx is your y, so we get y2 is equal to, taking minus b square e raised to ax, so minus common, I'm writing c1 cos bx plus this is c2 sin bx, and this is from 2 as we discussed, y1 minus a y1, so y1 minus ay, not y1, right, minus ay, okay, and plus, right, so see again, this is b e raised to ax, b e raised to ax, right, b e raised to ax, so here a is one more thing, so a is remaining, so we have to multiply by a here, got it, because this is only e raised to x into a, right, and here b e raised to ax, right, so a is remaining, and plus a by 1, this is due to 1 and 2, got it? Any problem? Now this is, what is this? This is e raised to ax, c1 b1 c1 cos bx, so this thing, this is your y from 1, right, so we get y2 is equal to minus b square y, y2 minus b square y plus a y1 plus a y1 minus a square y minus a square y plus a y1 plus a y1, right? So taking y common from this, and this is 2ay1, so we get y2 is equal to minus this is a square plus b square into y plus twice a y1, so taking these all terms to left hand side, we get y2 minus, I'm writing this first, twice a y1 minus become plus, this is a square plus b square into y is equal to 0. And if you want to express this term y2 and y1 in d square by dx square or dy by dx, then you can see this is d square y by dx square minus twice a dy by dx plus a square plus b square into y is equal to 0, right? That means we get, what is the given differential equation? So it means this, therefore y is equal to c1 e raised to ax cos bx plus c2 e raised to ax sin bx is a solution of this differential equation, right? So d square y by dx square minus twice a dy by dx plus a square plus b square y is equal to 0. Right? So this is a simple question of derivative, but you have to understand what is given and what is the required and what you have to do. Okay? Example number 26, page 416. Find the particular solution of the differential equation, right? While given condition is y equal to 0 when x equal to 0. So this is given. So this is log dy by dx is equal to 3x plus 4y, right? So degree of this function is not defined because this is not a polynomial function in derivatives. So applying this is a logarithmic function. So we are changing this into a exponential function that you know a raised to x is equal to y. A raised to x is equal to y. Then this exponential function can be written as x is equal to log y base a. Right? So this is logarithmic function, this is exponential function, right? So we have to convert this log into an exponential function. So log y base, nothing is given, that is base is e. We have to consider base as e. So what we get? Log y base a is equal to x. Then y is equal to a raised to x. Y is equal to a raised to x. So y is what? dy by dx. Right? आपको पता है ना, किक लगानी है, लगाओ किक. e नीचे गिर गया, ऊपर गया तो क्या हो गया? e takes this into a power. So e raised to 3x. This is everything in base. This is your line. So you have to write like this. This is everything in a power, right? So this is dy by dx is equal to e raised to 3x into e raised to 4y, applying exponential functions rule. Now this is a easily viewable thing, visual, that this is a variable separable form. So therefore dy upon e raised to 4y is equal to e raised to 3x dx. So this is variable separable form. So integrating, we get integration e raised to minus 4y dy is equal to integration e raised to 3x dx, right? So this is your question for integration. So now integration of e raised to x is no, but power of e is minus 4y. So we have to differentiate this, means coefficient of y is minus 4 and we have to divide by minus 4. So we get this is e raised to minus 4y upon 4, right? E raised to minus 4y upon 4, that is minus 4, right? Is equal to integration of this is e raised to 3x by 3 and plus c. E raised to 3x by 3 and plus c, right? So which is a general solution. So this is the general solution, equation number 1, right? Now given that y equal to 0 when x equal to 0. Now y equal to 0 when x is equal to 0. So y equal to 0 means e to the power is 0, that is 1. So this is 1 upon minus 4 is equal to e to the power, x is also 0, 0. So this is 1 upon 3 plus c, right? So c is equal to minus 1 upon 4 minus 1 upon 3. So this is minus 7 by 12. What we get? Minus 7 by 12. So this is minus 7 by 12, right? So substituting this value in equation number 1. So from 1 we get e raised to minus 4y upon minus 4, right, is equal to e raised to 3x by 3 minus 7 by 12. Minus 7 by 12. Got it? So, 12 is the LCM. So we have to multiply this by 3. So we get minus 3 times e raised to minus 4y is equal to multiply here by 4. So this is 4 times e raised to 3x minus 7. Taking this term to right hand side, we get 4 times e raised to 3x plus 3 times e raised to minus 4y minus 7 is equal to 0, which is a required particular solution. Which is a required particular solution. Question example 27, page 417. Solve x dy minus y dx into y sin y by x is equal to x dy x y dx plus x dy into x cos y by x. Right? So this is the given function. Here is dy, here is dx, y dx, dy. So multiply, what we get? If we multiply this, we get xy. So xy sin y by x into dy, because our first target is to express the given function in form of dy by dx. Then we can integrate that function for getting your answer, right? So minus this is y into y, that is y square sin y by x into dx into dx, right, is equal to, you have to multiply carefully. Okay, so this is xy cos y by x dx plus x squared cos y by x dy, cos y by x, I am putting brackets. Okay, so now equating the terms with dx and dy. So I am taking these two right hand side and this term to left hand side. So what we get, if we take y common, then xy sin y by x and minus x squared cos y by x, and dy is common. So taking dy common, I am taking these two right hand side, what we get, dx common. So xy cos y by x, xy cos y by x, minus become plus y square sin y by x and dx, right? So expressing this in a dy by dx form, we get dy by dx. dy by dx is xy cos y by x, right, plus y square sin y by x whole upon this, that is xy sin y by x minus x square cos y by x. Now we need y by x, this is xy. So if we assume y by x is equal to v, right, either first we take x square common, that is divide by x square numerator and denominator, we get dy by dx, right? We are going to divide by x square, so this become y by x cos y by x, because we are dividing by x square, so one x will be cut, y upon x, plus y square upon x square, that is y upon x whole square, and sin y by x, got it, whole upon divide by x square, so we get y by x sin y by x, and minus we are dividing by x square, so we get 1, right? So I am writing 1 here, so cos y by x, cos y by x. So this is a homogeneous differential equation, right? So homogeneous differential equation, this is homogeneous differential equation, right? So what we have to do, we have to assume y upon x as we, so we assume let y upon x is equal to v, so this implies y is equal to vx, so y is equal to vx means dy by dx, I am writing here because we need more space, so dy by dx is equal to v plus x dv by dx. This is, you know how to differentiate, right? So from 1 what we get, so from 1 we get dy by dx is v plus x dv by dx is equal to, this is v cos v, so v cos v plus v square sin v, right, whole upon, right? Be careful. Okay. So V sin V. मेरी गलती हो जाए तो कोई बताने वाला नहीं है, right? Cos V. Now we have to convert this into a compulsory variable separable form. So taking V to right hand side. I think we आपको हमको जगह कम पड़ेगी. So x dv by dx is equal to v cos v, right, plus v square sin v, right. Now we are taking v2 here, so we have to multiply by v here. So I'm writing directly minus v square sin v, right, minus v square sin v, right. So v is minus and this is minus, so minus minus plus v cos v whole upon what we get, v sin v minus cos v. Got it? पता चला ना क्या किया हमने? ऐसा किया, देखो x dv by dx is equal to v cos v plus v square sin v whole upon v sin v minus cos v and then minus v. So if you multiply this, then we get v square sin v as we write there, and minus minus plus we have v cos v. Got it? Now check. V square sin v will be cut. Very good. So we get x dv by dx is equal to, this will be cut. We get v cos v 2 times. So 2 times v cos v whole upon, this is v sin v minus cos v. v sin v minus cos v, है ना? थोड़ा कॉम्प्लिकेटेड लगता है आपको, मगर बहुत ही इजी इंटीग्रेशन इसका आने वाला है, राइट. So now changing into variable form, variable separable form. So this is v sin v minus cos v. I'm taking only v cos v. I'm leaving 2 here as it is. dv is equal to 2 times dx upon x, and this is variable separable form. So integrating and bifurcating also, right? So for reducing the step, integration, we will got sin upon cos is tan v dv minus integration cos cut v remaining 1 upon v dv is equal to 2 times integration dx upon x. 2 times integration dx upon x. Any problem? No problem. Very good. Derivative of tan v is log mod sec v. So we get log mod sec v minus log mod v is equal to 2 times log mod x. So arbitrary constant, all are in log terms, so we are taking log mod c, right? Log mod c. बहुत सारे बच्चे पूछते हैं मुझे, सर इसमें लॉग लेना है, किसमें लॉग नहीं लेना. मैंने बोला है आपको, as I discussed and told you, this arbitrary constant is your arbitrary constant, so you can choose any, right? But we are writing here why log mod c, for our easiest way, right? हमें कोई तकलीफ ना पड़े इसके लिए लिख रहा है. हम log c की जगह पर c लिखेंगे तो भी चलेगा, कोई दिक्कत नहीं. आपको जो लिखना है वो लिखो, मगर आंसर आना चाहिए. एग्जाम में क्या होता है कि आपका ये इंटीग्रेशन आया वो सही आना चाहिए और इसका आंसर जो ये है वो करेक्ट होना चाहिए. यहाँ पे log c लिखो, c लिखो, whatever you want to write. But I want one arbitrary constant. For our simplicity, we are writing log c, right? So now this is log a minus log b is log a upon b. So this is log a upon b is sec v upon v is equal to, now taking these two here, we get log x square. So log a plus log b is log a into b. So we get log x square into c. Log x square into c, right? So now log is a one function. So removing function and substitute value of v, that is v is y by x. So we get sec y by x, right? Whole upon v is y by x is equal to x square into c. right? Now taking x is c, so we can write sec y by x, right? If we multiply x square here, then 1x will be cut, then this is xy, what we get, upon x y. So this becomes, I am writing here, okay, I am multiplying here, leave it, right? So this is c, right? तो क्या होगा, x ऐसा हो जाएगा ना, x square into y by x, so it is becomes xy, right? Which is a required general solution, which is a required general solution. Or if you want to write in this answer in cos, then take these two here, then it become 1 upon sec. 1 upon sec is cos, and c to this side, that is it becomes 1 upon c, and assume 1 upon c is equal to c, so you can get what your answer is given.